Hello and welcome to the How We Code channel. Today we're going to be talking about our first document-based database, MongoDB. For those of you who don't know me, my name is Howie Reith. I'm a software developer who's enthusiastic about learning new things and sharing them with others. If you have any questions about this presentation or would like to reach out to me in general, you can do so at howard.reith@gmail.com, and of course always feel free to leave a comment on this video with specific questions. Talk a bit about what we're going to be talking about today. We'll learn how to set up Mongo on your computer, talk about basic create, read, and update and delete commands. We'll talk about references, which is basically how you connect documents that are located in different collections. We'll talk about some of the query operators available in Mongo. We'll talk about how Mongo does its indexing, and lastly we'll talk about a particular operator called the lookup operator, which is used for essentially a left outer join. So let's talk about installation. What you're going to do is you're going to go to docs.mongodb.com/manual/installation, and that is going to provide you with instructions on how to install Mongo on whatever system you may be using. For the purposes of this presentation, I will be using Ubuntu 20.04 using Windows Subsystem for Linux. Now, when I get started with sudo service mongodb start, and then simply enter in with Mongo. I'm going to illustrate that for you right now. Then we go in with Mongo. So a brief overview of Mongo. It's the most popular document-based database in use today. In terms of CAP, it prioritizes availability and partition tolerance. It is built for extensibility. Mongo comes from the word humongous, so it is built to be on very large datasets. It offers indexing and powerful queryability, which provides it an advantage over other NoSQL databases. And its documents are JSON-like objects that mesh very well with JavaScript-based web applications. It is thus very popular in the web development community. So let's talk a bit about CRUD operations. So first of all, if you want to view all of the databases you have available, you type in show DBs. This shows everything that I have on my system right now. And to go into a particular database, you type use and DB name. Now, like the last video on Postgres, we're going to be making an event planning application. So let's turn our database into events. And then if you type in DB, it will tell you which database you are presently working in. So the way Mongo organizes its documents is into collections. You can basically think of any given collection as like a folder that's holding all of your papers. You have a collection that is holding all of your documents. So when we go into our terminal here, if you type show collections, that'll show all of the collections we have in our events database. Presently, we have none. Now, if we want to create a collection, all we need to do is insert it. And as you can see right here, we are going to be creating the cities collection. So if I copy this command right here and paste it in, you will see we have created the cities collection, and we have inserted New York into it. And if I do another show collections, you'll see cities has now been created. You are in fact able to create collections without inserting anything into them, and we're actually going to do that a bit later on. But this is a bit speedier. Mongo is kind enough to just automatically upsert anything that doesn't already exist when we want to insert something into a collection. So to verify that we've successfully inserted New York, let's go ahead and do a dbcities.find. This is your generic get query. And as you can see, it's already assigned an object ID to it, and we have the name of New York in there. Now, in the event you want to have your JSON printout come out a little bit easier to read, you can do pretty, and it's a bit too small here, but let's say you had a really big JSON blob, which we probably will in the very near future. You can do .pretty at the end of it, and it will organize it into a prettified JSON document. So let's say we want to use find to find a specific document. At the moment, all we have is New York, but the way you do that is you pass in an object as a parameter into the find method right here. So we want to find by name New York. So if we grab this guy and stick it in, you can see, voila, it has successfully found New York. And just for comparison, if we were to find New York, it's not going to find it. There is no city in the database named New York. Now, if you are finding a document by its ID, you need to surround that ID with the object ID function, because it is a specific type of data type that you are using when you are searching for an ID. So if we were to find this guy right here, we can take a look, and voila, we have successfully found New York by its ID. So needless to say, we're working here with a document database. We deal with entire JSON objects, and they can be a whole lot larger than key-value pairs. So let's do that. Let's insert Boston as one of our cities in our database. And boom, you've got all of this information about Boston. And if we want to do a find by name Boston, and if we do a pretty on it, you'll see we get a much prettier illustration, a much prettier JSON document for Boston than we probably otherwise would if we did not do the pretty. So when you are doing a find can actually accept an optional second parameter. So if I wanted to do a find of Boston, but all I wanted to see was its name, I could do this and boom. It will still show me the object ID for the city, but it will also show the name. And just to clarify, when you are doing a name one, think of this as like true or false, right? So name true. When you're doing that, then you are only going to get the name back along with whatever else you pass in. If you do 0, then it's going to give you everything except what you list in this parameter right here. So that can help you quite a bit when you are looking for more specific items inside of your collections of documents. So let's look at inserting multiple things at once. There's a nice handy little command for that. It's just cities, db.cities.insert many. We're going to add Las Vegas, Los Angeles, and New Hampshire. And boom, it's automatically assigned object IDs to all of them. Now let's say we want to sort the results coming from our find method. So sort accepts as an argument the fields that you want to sort by and an integer. Now, if you input 1, that is going to be you are sorting ascending, or if you do -1, that is going to be sorting descending. So to illustrate, let's grab all of our cities and we're going to sort them by ascending. And as you can see, we go Las Vegas, Los Angeles, New Hampshire, and New York. If we want to count the number of documents returned by our find statement, that is simply after find, you append a .count method. And as you can see, we have 5 cities. And if we want to sort, well, if you want to limit the number that is returned back, in the illustration here I do it by sort, but you can just append a limit without a sort if you want to, and this will only give us the first 2 cities that are returned. Now let's say you only want to find 1. Well, fortunately, Mongo has a nice little method for that. It's called the find1 method. And boom, it returns the very first one it finds, which in this case is New York. And also, like in JavaScript, you can perform a for each method on the values returned. By the way, there's a lot of JavaScript in Mongo. It's built to emulate JavaScript in many respects. So if there is something that you are accustomed to using in JavaScript, maybe not ES6 or ES8, but in core-based JavaScript, there's a decent chance it's available inside of Mongo. So in this case, we're going to use a for each, and we are going to print out the mayors of all of the cities that have mayors in our database. So at the moment, that's only really Marty Walsh, but as you can see, it prints them out. So now let's talk about updating. Now, when you're updating in Mongo, you got to be careful, because when you do an update, it is going to replace the entire document. So if I went in and I just wanted to add the mayor of New York, or let's say I wanted to update Boston, and I just wanted to change the mayor to a new hypothetical mayor. If all I did was find it and then say Mayor Boston, the new mayor, that new document would consist of nothing but a key value pair that is the mayor and the new mayor's name. Okay, we'll talk about how to update specific fields later on, but just be aware, if all you are doing is an update, you are replacing the entire document. So be aware that that's what you're doing. So in this case, we are going to add Bill de Blasio as the mayor of New York, and we are in fact going to replace the entire document because all we have in New York at the moment is the name of the city. So voila, we have successfully done it. If we do a db.cities.find name New York, you'll see we now have name New York Mayor Bill de Blasio. So we can also add additional parameters to update. For example, there is an upsert that makes it so that if it cannot find a value inside of the document, it will automatically put it in there. So if we were to do db.cities.update Chicago with Lori Lightfoot as mayor, we're going to find out that it did not do what we wanted it to do. If we do this lookup of Chicago, it's not going to be there. But on the other hand, if we were to do this with upsert true, Chicago now exists and has Mayor Lori Lightfoot. Now let's say we want to modify only a particular key value pair within the document. In this case, we're going to be using the very first one of our operators that we're going to talk about, the set operator. So in our update, for the first parameter, we are going to, as usual, pass in the one that we are looking for. And then we are going to have an object wrapped around the set operator. And then set, for its value, is going to receive another object. And it's going to have the field that we are updating and the value that we are updating it with. So when we perform this update, when we take a look at db.cities.find name of Boston, we will have successfully updated our industries with lobsters as one of the industries of Boston. And note that we have done so without deleting any of the other contents of Boston. So now let's talk about deleting. Oh no, someone has informed me that New Hampshire is not, in fact, a city. Well, to fix that, what we can do is we can use the remove method. Very simple. All you pass in is the key value pair identifying what it is you want to remove. In this case, we want to find the city with the name of New Hampshire, and we remove it. Now, similarly, there is a delete one function that will effectively do the exact same thing. It will delete the one thing that matches the filter that is passed in, but we have already deleted New Hampshire, so I cannot demonstrate this for you a second time. So what if we want to delete several documents all at once? So in preparation for illustrating this, let's go ahead and add a whole bunch of dummy cities. And now let's delete them all by filtering for the property of delete me that is inside of its document. And there you go. If I do a db.cities.find with the property of delete me, I will not find anything at all. You can also delete all documents in the collection by putting an empty object inside of the delete many method, but I'm not going to demonstrate that for you because we want to have these documents available for future parts of this presentation. I also want to mention that we haven't tackled indexing yet, but you should be aware that if you do create any indexes on your various documents, deleting all of the documents is not going to delete those indexes. So you need to make sure to delete those indexes separately if you go ahead and delete all of the documents that they would be indexing. Lastly, if you want to delete a single key value pair within your documents, you can use the unset operator. This is, of course, the opposite of the set operator. Like the set operator, we are going to have an object that is wrapped around the unset operator, which has the value of the key and the value we are looking to unset. So when we run this, that has now been unset. And if we do a find on Chicago, we'll find that we no longer have a mayor in there. The unset has been successful. Now that you know all of the CRUD actions in Mongo, how about we do an exercise? How about you create a city in the database, update it, replacing the entire document, update it again, adding or changing only a single field, then retrieve your city from the database using its name, and then delete your city. All right, let's move on to the next topic, which is a bit more interesting and a bit more unique to Mongo, the topic of references. So in our document database, we're going to have 3 types of documents: cities, venues, and events. We need to think very carefully about how we want to structure this data. And in order to make that evaluation, we need to know a bit about how Mongo deals with references. So a reference is when you use one of the values in the document to link it to another document using its ID field. Now, if you want to retrieve the data from a linked reference, Mongo is going to need to do an additional query. So for example, let's say we have a venue that is linked inside of a list of venues inside of our city. If we want to find the first venue, what we're going to need to do is we first need to find the city, then we get the array of venues out of that city, and then we need to do an additional query that is going to go and retrieve that other document at another part on our hard drive to get the data concerning our venue. Now, whether or not that is a proper course of action depends a lot on the sorts of queries we are frequently going to be running. So let's go over them. Let's go over 3 possibilities that concern the extremes. So let's say we only have one collection, a collection of cities. Let's say we only have one collection, one of events. And then let's say we have 3 collections that we connect via these references: cities, venues, and events. So what are the costs and benefits of each approach? So what happens if we only do cities? Well, the nice thing about only doing cities is that if we want to get all of the information on a city, we only ever have to make one query. We just say, give me everything there is on Chicago. And then we go and retrieve Chicago, and we will get every single venue and every single event in every single one of those venues that's happening in Chicago. We don't need to be making multiple queries. We don't need to be writing any complex code. It's just, give me the thing that has this name, and you get back everything about that. So that's pretty cool. But what are the downsides of that? Well, let's say we have events that are going across multiple cities. Let's say we have venues that are in a franchise across multiple cities. Let's say you want to do a query to retrieve all events that are happening anywhere, regardless of what city they are in. Think about what the computer has to do in order to do that. It needs to go through every single city, then every single venue, and collect all of their events, regardless of whether or not that city has any venues or that venue has any events. So it's also going to be very difficult to model any events that don't necessarily take place in a city. For example, a holiday. This is also going to require a fair amount of hand jamming. So like I said, if you have events that span multiple cities, those cities are going to need to have duplicates of those events that are probably going to need to be done by hand, or else you're going to need to write duplication logic to do that. So obviously, easier retrieval of stuff if all you care about is getting stuff by city, but everything else is more difficult. So what if we go to the other extreme? Our only collection is going to be events. Well, this is great. You can quickly and easily acquire all data concerning a given event. However, we have the reverse problem. If you have multiple events happening in the same city, and you want to have city information replicated in every single one of these events, well, then you're going to have to do a whole lot of duplicated effort. You're going to need to retype that information into every single event, even though it's all the same information. So that's a lot of extra hours spent by some poor administrator somewhere just typing stuff when they don't necessarily have to. Likewise, if I want to find every single event in a given city, I will need to iterate through all events and then filter out all of the events that aren't in the city that I want it to have. So that can be a bit time-consuming as well and not particularly efficient. So let's say we have 3 collections, cities, venues, and events, and we link these 3 collections via references. So in this case, you only need to enter the data once per document, and anytime there's going to be any commonalities between these documents, you just do references and you don't need to worry about it. But now, every time you retrieve an individual document, the process of that becomes a lot more complicated. If I want to get every single, all of the information concerning a particular event, and I want to get its venue information and its city information, then Mongo needs to query the event, then it needs to query for the venue, and then it needs to look in the venue to find out what city it's in, and it needs to query for the city. So I have 3 queries that need to run just to get all of the information I want from an event, as opposed to the old version, all I needed to do was do one single query. But on the other hand, I have saved myself a lot of time and a lot of unnecessary duplication. So, It's up to you. Whatever course of action is best for you is going to depend on what sort of queries you are frequently going to be doing. Now, in my personal opinion, for our use case, we are frequently going to be looking up city information, venue information, and event information. And we don't necessarily need all of the other documents for every single query we're going to write. So the least expensive way to do most of what we're going to be doing is to store them as 3 separate documents connected, and in the event that we need to find the information for all 3 collections in any given query, we're just going to have to run those additional queries when that happens. So let's go ahead and create these other collections. Remember how I said you can create collections without necessarily inserting? Well, let's go ahead and do that. We are going to create a collection called venues and create a collection called events. And just to make sure everything has worked correctly, let's show our collections and see that we now have 3 collections: cities, events, and venues. So now that we have our new collections, let's add some venues. So our first venue, we're going to add 2 venues actually. These venues are going to have a name, address, and activities that typically happen at these venues. So we're going to add my favorite karaoke bar, Courtside. And we're going to add a Chinese food restaurant that also happens to do karaoke called Hong Kong. And boom, we have added each of these to our database. Now before we move on, I want to tell you about another decision we need to make. There are 2 types of references in MongoDB: dbrefs and manual references. dbrefs were an effort in MongoDB to make joining between collections easier than it was. It is essentially an object that contains the database identifier, the collection name, and the ID of the target document, while a manual reference is nothing but the target document's ID. So the idea of a dbref is that using a dbref, you should be able to locate the location of this document no matter what. It has all of the information you need to find it, while with a manual ref, you must know the database and the collection that you are looking in, otherwise you will not be able to find this because all you have is its ID. So dbrefs are useful for situations when you are running the same query across multiple databases or collections. But generally speaking, that's not the case. That is a pretty uncommon situation for you to be in, and most of the time, you're going to want to be using manual references. One reason for this is they're simply simpler. It's easier to use a manual reference, but more importantly, there are some aggregation functions that we're going to be working with later on that you cannot use dbrefs with. You have to use manual references. So if you want to be using those functions, you want to be doing manual references. But we're going to talk briefly about dbrefs because there are various pieces of software, like if you have a backend and you're using a library that's going to be using MongoDB, there's a chance it's going to be using dbrefs whether you want it to or not, and it's useful to simply understand a little bit about how these are implemented. So let's go ahead and create some dbrefs that will connect Courtside to Boston. So I've already done a dbvenues.find and a cities.find Boston to get their information. So this is the update we're going to run. We're going to do an update. We're going to find the venue, Courtside, by its ID. And then we're going to use this set operator to set city equal to, and then we're going to use this ref operator. This ref operator, when you're doing a dbref, stores the collection that the document you are looking for is in. In this case, we are looking at the cities collection. The ID operator stores the _ID value of the document that you're looking to connect. So in this case, it is the object ID associated with the city of Boston, which is this guy right here. So if we grab all of this for the updates, we will have successfully updated our venue of Courtside to have the city of Boston. So if I do db.venues.find name Courtside, we see that we now have this dbref inserted in there, and this dbref will link us to the cities collection to the Boston document. And just to verify that, we can do a db.cities.find1 with an ID equal to the ID that is inside of courtside. And voila, it has given us the information about Boston. Now just take a look right here. When you are doing this reference inside of a dbref, you do need to have the ID operator, the $ID. You cannot just do _ID, it will not understand what that means. So now we've created a link from courtside to Boston, but we have no reference in the other direction. So let's go ahead and add courtside to the venues array inside of Boston. So we're going to do an update. We're going to set venues into an empty array just to make sure it exists. And then we are going to push into that array our dbref in the venues collection, the object ID associated with courtside. And note here that we are going to be using the push operator to do this. Push is obviously something that you would use when you are adding an element to an array. So we grab all of this, put it in, and boom. If we do db.cities.find name of Boston, you will see we now have a dbref inside of our venues array. And if we grab this, we look at the first venue in that array, we see that we are now able to access courtside. So now that we've got this working for courtside, let's go ahead and create a manual ref for Hong Kong so we can see how it's different. Now you'll notice this update statement is a little bit different here. We don't have to be setting the dbref stuff. All we are adding is we are setting the city equal to this object ID. So we don't have any information in there about what collection it is in, but since we, the humans, know that we're always going to be looking inside of the city's collection whenever we run a query for this, we don't really need to worry about it quite so badly. So we do this, and boom, we have successfully added Boston as the city to which Hong Kong belongs. So the next obvious course of action is to go ahead and add Hong Kong to our array. But since we have a dbref for courtside and a manual ref for Hong Kong, let's go ahead and replace the dbref that courtside has with a manual ref, since that's what we're going to want for the rest of this presentation. So I'm going to grab this update statement and paste it in. We have written, and let's just make sure that it is good to go. And boom, we are getting Boston. It is now connected properly to courtside. All right, now let's go ahead and update Boston so that way it has the proper manual ref for its venues. And let's make sure that is working right. Good, good, good. We have courtside. And now let's actually update Boston to push in our second venue of Hong Kong into that array. Let's make sure that has successfully stuck. There it is, it's Hong Kong. And now let's go ahead and look at our full array. There it is, both of the items in our venues array. Now, I don't know about you, but I thought setting up these links to match both ends was pretty cumbersome, and I'd rather not be doing that every single time I want to add a new city and venue. So let's make things easier by using another function, another functionality that that MongoDB has, and it is called, you can basically add JavaScript functions and save them into your database. So we're going to create a function called addVenue2City that's going to accept a venue ID and a city ID, and it is going to do all of the logic that we have just figured out thus far. So we copy this, we paste this in, and boom, this function now exists in MongoDB. And we're going to add another function called showVenuesInCity. So to make sure those functions are working, let's go ahead and add the Metropolitan Opera House to our list of venues. So we're going to have to do an insert. I've actually already done that. And then if we add a venue to a city, we pass in the object ID of the Metropolitan Opera House and the object ID of New York City. We stick them in, and boom, that appears to have run. And let's see if it works by running our showVenuesInCity. And there is the Metropolitan Opera House, the only current venue existing in New York City in our database. All right, so here's a challenge. Create an event in your events collection. This event should have a name, a date, time, and tags. And note that in order to do a date time in Mongo, you are going to do a new date and pass it in with this format right here. Year, month, date, then a T, hours, minutes, seconds. And this is going to be local time. Then, add a venue field to your event and link it to a venue. And then, add an events array to the relevant venue and add the event that you created. Write a function for linking events to venues, and write a function for getting all events in a venue. And if you want some real extra challenge, write a function for getting all the events in a city. The returned printouts should include the venue names above those event JSONs. Here is a little hint for that. If you find yourself needing to check the truthiness of anything, you can do if statements to do so just as you would in JavaScript. All right, I'll be back in a solution in just a moment. Welcome back. So the first part of these solutions is mostly copy pasta from the previous ones that we were working with. I have created an event called Karaoke Night. It's going to have a date time of a new date. Let's say it's September 30th. And it's going to have tags karaoke, drinks, and music. We are then going to update this event to have courtside as its venue. We are then going to update courtside to have among its events this new karaoke night event. We are going to add a function to our database called add event to venue. This is essentially the same logic as the other one. We are also going to have show event in venue, which is also very similar logic to our previous show venues in city. And just to make sure this functionality works correctly, we are going to take a look at show events in venue, and boom, we have karaoke night occurring at courtside. Now for the big one. Let's talk about show events in city. So to do this, we are going to find the city by the city ID. We are going to look through all of its events, and for each one of these events, we are going to set a variable venue equal to the venue ID of what we are currently for eaching at. This is where we're doing some logical stuff, so not all of your events are going to, not all of your venues are going to have an events array. So we're going to check to see if the events array exists. And if it is, then we're going to for each through each of those events, and we're going to print what venue we are currently on, its name specifically, and we're going to print all of the information about this event by looking it up via its event ID in our events collection. So we just put that function in, and then now let's look at all of the events we have in the city of Boston. And at the moment, all we have is this karaoke night at courtside. Let's move on to part 4, operators. So operators, we've already been exposed to some of them. If you would appreciate a full list of all the available operators available in MongoDB, I recommend going to docs.mongodb.com/manual/reference/operator. Just to briefly go over the operators we've already looked at, we have set and unset, which add and remove keys to a document respectively. We have ref and ID, which are used in the context of dbref. They store values inside of them, the collection for ref and the ID for ID. And we also have push. This is an operator that is used for adding a value to an array. So let's go through some additional powerful operators that are in our tool belt that you are probably going to want to know about. And let's start with query operators. So the first one is EQ. This one matches documents with the fields that matches the specified value. So for example, if we want to take a look at all of the events that have the karaoke tag, this will look through our database, it will look inside of the tags, and it will actually even look inside of the array and iterate through each item in the array and find karaoke and say, hey, this one has this, I'm going to return this document for you. So this is just an equality check. This is actually very similar to, even if we didn't have this operator, you could just look for karaoke specifically and it would return the same way. But this is, if you ever see EQ, that is what this is doing. So regex, this will do a very similar thing, except it will match a regular expression as opposed to an exact match. So in this case, we are looking for any tags array that has inside of it a string that contains K-A-R-A. This, once again, finds our karaoke night with the karaoke tag inside of it. So in is going to match documents that have certain values inside of an array. So if there are any documents that have either karaoke or opera inside of activities inside of the venues collection, this is going to return those documents. And as you can see, we have gotten our Metropolitan Opera House, and we have gotten Hong Kong, and we have Courtside, because the latter two both had karaoke, and the Met has opera. So GT and LT stand for greater than and less than, respectively. Obviously, you're going to need to use these with numerical values, not with strings. But in this case, let's go and take a look at the median age demographics value and see if we can find what we expect. And indeed, we have found Boston with Marty Walsh and all of that other information in there because the median age is less than 35. Moving on with some more query operators, we have an exists operator that checks essentially truthiness. Does this exist? So I'm going to find all cities that have any value whatsoever for mayor. And boom, once again, we have found Boston. NE selects all documents that do not equal, so it's not equal a particular value. So I am going to find all cities in our database that are not equal to Los Angeles. And of course, we get all of our cities except for Los Angeles. We have Las Vegas, Chicago, and so on. NIN finds all documents that do not have the items in the array. So I am going to find all events that do not have dolphins inside of its tags array. And this should return our one existing event because it does not have dolphins in the tags. Now let's talk about logical query operators. This is and, not, nor, and or. You are probably familiar with these. These are just like when you are doing logical comparisons between various objects in whatever programming language with which you're most familiar. That is what these are doing. So and is a joins query clauses with and, the logical operator and returns all documents that match the conditions of both clauses. So for example, we're doing a venue search. We have the and operator here, and we're going to find venues where they have events and where the activities include karaoke. And as you can see, Courtside is the only one that appears because Hong Kong does not have any events, and karaoke does not exist in the Metropolitan Opera House. You can do very similar queries with not, nor, and or. Not returns documents that do not match the query expression at all. Nor performs a logical nor and basically returns all documents that fail to match both of the two clauses you passed in. And or will match any documents that match either of the two clauses that you pass in. I'm not going to demonstrate those because those are essentially the same as these, but feel free to experiment on your own. Next, we're going to talk about where. So be careful not to expect where to behave too much like it would be in a SQL. Basically, what we're doing is we are passing in a function, and we can make our JavaScript function behave however we want it to, where it gives us a lot of freedom. But you need to be very careful with it. Where is not going to use indexes. It is going to go through all of the documents purely one by one, and it is not going to do anything particularly efficiently. So you are better off looking at the currently existing operators in Mongo and trying to find something that suits your need. But if you happen to have a use case that Mongo simply does not provide out of the box, then you can go ahead and write your own JavaScript function to find what you need it to find. So in this case, we are just going to search through the database to find where the name of the city is equal to Boston. Obviously, we would never do this in reality because it's far too inefficient, but this is a functionality that is available to us. Now let's talk about update operators. So current date will set the value to the current date in the field that you pass in. So we're going to update our karaoke night event, and we're going to set the last modified field equal to the current date. So note, you are doing the object wrapped around this operator, and you are saying I am doing current date, and current date I want to be, you pass in the fields that you are modifying, and then you say true to say yes, this is the one that I want to be modifying. So if we perform this, and then we were to do db.events.find name karaoke night, we will now see that it has a last modified value of right now when I am recording this. So increment will increment the value of a field. If we do db.cities.update of the male demographics, I guess somebody just got born in Boston, we can start off by doing a db.cities.find with name Boston, and we should be able to see our demographics. Male is 283,588. After we run this query, if we do that again, we will now see we have 589. I'd also just like to comment that if you need to dig into nested data inside of your document, this is how you do it. You see how we're doing demographics.male as opposed to just going directly for the higher level field. So what you do is you turn it into a string and you dot into it like this, and then you are able to modify it with your operators right here. Very powerful tool in Mongo. It is one of the things that makes nesting so much easier to deal with than in other database types. So renames a field in a document. So for example, let's say we don't like last modified being called that anymore. We want it to be called last updated. In this case, we once again wrap an object around our operator. We say we want to rename. We are renaming last modified, and then we are setting it equal to last updated. And voila. And if we take a look at karaoke night, it now has last updated. Moving on to one of my favorite topics, indexing. So one of the appeals of MongoDB is that it can actually have indexes, and this is something that a lot of NoSQL databases don't offer. Now, unlike SQL databases, at least as well as I can tell, Mongo does not have clustered indexes. And I think the reason for that is because you can't have, you aren't guaranteed to always have the same sized documents. Different documents, there's no constraints on them, and so they can always be different sizes. And so you don't have guarantees of where your pointer needs to point on the disk in order to get to the next document. It's always going to be bigger or smaller, and you can't make such assumptions. That having been said, when you have an ID field on your document, that is automatically indexed. And these indexes work in much the same way as indexes do in SQL databases. By default, they're going to be set up as binary trees, and they are going to be sorted in order according to the ID. So whenever you are looking for an ID, looking for a document by ID, Mongo is going to be able to perform binary search and locate those things very quickly for you. Likewise, if you sort things alphabetically, Mongo will be able to use indexes to find the relevant documents very quickly there as well. So, since data types can vary so considerably between documents, Mongo requires that when you create an index, you need to specify the type of index that it's going to be. So for example, is it going to be text, is it going to be numbers, and so on. So the createIndex function accepts an object, and the key of that is going to be the field that you are looking to create the index on, and the value is going to be the type of that field. So for starters, we are going to create an index on the name field in our cities collection. And voila, we have now created that index. Now with a text index in place, we can perform text searches across documents, and this is the way that works. So you have the text operator and the search operator. So this is going to be full text search. So every single one of these fields that we have added to this index, obviously here is pretty short, it's just going to be name, but you could hypothetically have entire paragraphs of text inside of these fields that you could do this search on, and it's going to help you find stuff a lot quicker than you otherwise could. So in this case, we are going to search for Boston inside of our text field of name, and we have found it, and it returns the Boston document to us. So here's an exercise. Go ahead and add text indexes to the name fields for venues and events. Feel free to pause the video, and we'll be back in just a moment. All right, moving on. Here is the solution. Let's go ahead and create a text index on the names for venues, and let's do the same thing for the names on events. Mongo also offers what's called compound index. This is essentially creating an index with prioritization on multiple fields. So let's say here, we are going to create an index on events for date, time, and tags. And you'll notice here that we have a -1 and a 1. This determines whether your index is going to be sorted ascending or descending. Now, when we are creating this index, what I mean by prioritization is the index is first going to be sorted by date, time, and second by tags. Consequently, since it is sorting by date, time first, we are de facto creating an index on the first field that we are creating this compound index on. So since it is always going to be sorted first by date time, Mongo is going to be able to iterate very quickly through the sorted date time to find relevant documents and return those to us. It's just after it has found something with the relevant date time, it will then be able to go through the index for tags as well very quickly. So let's go ahead and create this index. And this is date time descending, tags ascending. And voila, we have created another index on our events. So you may have noticed when we created that index that the second thing, the tags that we created it on, was an array. And you might have gone, whoa, how on earth is Mongo creating an index on an array? Well, Mongo has a feature called multi-key indexes. And multi-key indexes essentially automatically create an index on every single item inside of the array, assuming that it is an array. So if we create an index on activities, which is an array, and we're doing it ascending on our venues collection, what that is going to do is that is going to create a binary tree sorted list, so to speak, on every single item in the arrays of activities. And it is going to then have pointers to the relevant documents. It's going to say, hey, you're looking for this activity. Okay, it is located in these documents. Here are those documents. Now, as with relational databases, we need to be careful with creating indexes. They have the same pros and cons as they do in relational databases. Any writes you make to your documents are going to be slower because they need to update the indexes as well. If that means rebalancing trees, if that means adding more stuff to these indexes, all of that is going to need to happen. So you have gone from O of n for reads to O log n for reads, but you have also gone from O1 for writes to O log n of writes. It's up to you if that's worth the trade-off, but suffice to say, you probably don't want to be adding indexes except on the values that you are frequently going to be querying. Also, you need to keep in mind, adding indexes means more disk space and more memory space required in order to run this database. So, be advised, make intelligence choices, don't add indexes to absolutely everything, but they have a lot of advantages, so don't be afraid to use them either. Let's talk about the last section, lookup. Now, there are a variety of union functions, I don't know, aggregate functions. There's several things that we could call this category of things. Mongo is not particularly good at doing unions. It's not built for that. It is built for storing items in documents and keeping all of the data relevant to that document inside of that document. That is the way you want to be thinking of structuring your data, and you only want to be doing unions between collections when you really need to. Okay, these should be the exceptions to the rule rather than the rule. If you really need to be doing unions between relatively unrelated data very frequently, you probably want to be taking another look at relational databases or something, maybe even a graph database. But suffice to say, there are mechanisms in MongoDB to be doing unions, and this video is getting long, so I'm only going to talk about one of them, but that one is a pretty powerful one, and it's the lookup operator. So what lookup does is it is essentially doing a left outer join between your current collection and your targeted collection. Now, previously, we wrote a bunch of methods to figure out like all of the information about a city for a given venue, right? Or all of the information about a venue, all of the venues for a given city, right? We wrote functions to accommodate our needs in order to do these joins between these related but separate collections that our documents were concerning. Another approach that we could have taken to do that is with the lookup operator. Say, this isn't something we necessarily need to do all the time. We have one particular query that we need to do in order to get a particular set of information about a whole bunch of different documents that are in different collections. So in that case, we want to do a left outer join perhaps, and we will use the lookup. So here's how a lookup works. The lookup operator is going to have 4 parameters passed into it. It's going to have from, that is the collection that you are going to be joining with. You're going to have a local field. This is the field that has the same information as the field that you're going out to, right? This is your foreign key. Then your foreign field is the equivalent key on the other collection that you're looking at. And as, this is how it is going to print out inside of your terminal. This is the value that is going to be shoved onto your JSON objects to include the information that this lookup collects. So this is going to make more sense if we do it like this. So we're going to be performing a lookup between our cities and our venues. So cities is our current collection. We're doing a .aggregate on it because we're going to aggregate a whole bunch of different documents from across cities. It is thus going to have an array, and we are going to run lookup from the venues collection. Our local field inside of our city is going to be the venues field, and the values inside of the venues field are going to be mapping to the ID field inside of the venues collection. Now note, if we had DB refs here, those DB refs would be containing like a whole bunch of different information, right? They would have the collection, they would potentially have the database, and they would have the ID. And while it is not impossible, it is quite difficult and takes a lot of code in order to properly dig into the DB ref in order to do what we are doing right here. This is why we changed our references to be manual references rather than DB references, because it makes running this lookup infinitely easier, because all we need to do is pass in the venues array rather than having to do a whole bunch of magic to try to dig into the DB refs and get the IDs that we want. So the IDs in venues are equal to the IDs inside of the actual venue objects, and we're going to spill this out into venue info inside of our JSON returned. So let's see how this looks. And there we go. We have performed a left outer join that grabs all of our cities and dumps venue info inside of, you know what? I am going to pretty this. All right. And dumps all of our venue info. So obviously there are no venues in Las Vegas, Los Angeles, or Chicago, but we do have venues here inside of Boston, and this gives us all of our venue info. So when you want to be doing these sorts of joins and collecting, say, all of the venues inside of a city, this is a quick, easy, and efficient way to do it. It's probably more efficient than queries that we would be writing ourselves. Now note, if you're working with an old version of Mongo, or if you're looking on Stack Overflow trying to find this stuff out, in older versions you had to unwrap these arrays, but in more recent versions you can pass in arrays directly and it will unwrap them for you. So Mongo programmers, thank you very much. That is very beneficial. So here's a final challenge for you. Perform a lookup between 2 other collections in whatever direction you would like. So if you want to do a left outer join between events and venues, or between venues and cities, whatever you like. Just do not repeat the one that we just did. And with that, thank you very much for watching. Here is a bibliography. As always, the PowerPoint presentation is going to be linked to my GitHub containing it in the description. So you will be able to access the links in this bibliography and the links throughout here. And if you would like to just take a closer look at any of the code that is freely available to you, I hope it is helpful. Once again, my name is Howie Reith. Feel free to leave any questions or comments inside of this video, or you can reach out to me at howard.reith@gmail.com. Thank you very much for watching. I hope this was helpful. Have a good one.